So the next video is going to talk about the cross product or vector product. This was actually introduced back in chapter 12-6, and there's some more information in this chapter, chapter 14-2. Okay, so what is the cross product or the vector product? So what it does, so this is if you have two vectors, so you multiply two vectors together and you produce a vector. So that's known as the vector product or the cross product. Now, there's also something called the scalar product, or also known as the dot product, that multiplies two vectors together and actually produces a scalar. So we'll talk about that next week, actually, once we get to work. Okay, so again, this was introduced back in chapter 12-6, although I kind of skipped over it when we were doing chapter 12. So, and one of the things you can do, so if you just want to know the magnitude of the cross product, right? So your cross product, it's going to produce a vector. The magnitude of that vector resultant that it produces, so if you have two vectors, vector A, vector B, and there's some angle phi in between them, so the cross product or vector product is known as A times sine B, right? And it's actually important because we use the little times sign to indicate the vector product or the cross product, which is part of the reason why it's called a cross product. Whereas the scalar product or the dot product, you use a dot. So they're actually different. So, but if you just want the magnitude of this, you just take the magnitude of vector A, the magnitude of vector B, and multiply by the sine of this angle phi in between them. Okay, so some of the properties. So first off, so if you actually want to calculate this thing, including in all its gory detail, so usually the way I like to think about it, so you think of it as a 3x3 matrix, right? So vector A cross product with vector B. So you write a 3x3 matrix. So top row is your component vector, or your unit vectors, I hat, j hat, k hat. Then the components of vector A sub x, A sub y, A sub z. Then the components of vector B sub x, B sub y, B sub z. And then if you've ever taken the determinant of a matrix, so it's actually the determinant of this matrix gives you the result of the cross product. So we'll actually do this well, I'll do an example of this in class. But essentially what you're doing is you're multiplying on so you take the diagonals that go down and to the right, you multiply those together, and then you subtract the diagonals that go down and to the left. So we'll do an example of this in class so you can see how it works. Now, one of the important things to remember about the cross product is, so it produces a vector, so it has a direction. And the direction of the resultant is perpendicular to both of the vectors you started with. Right, so if we have vector A and vector B, we take their cross product. The resultant is actually going to be perpendicular to both of them, sometimes called the binormal. So it's given, you can find it by the right-hand rule. So in the way I like to do the right-hand rule is shown on the top here in the image from your book. So if we have vector A cross product with vector B, point your fingers in the direction of vector A. You bend your fingers in the direction of vector B, and then your thumb gives the direction of the resulting cross product between these two. So, and another important thing about the cross product is that the order matters. And here's just some other random properties that sometimes come in useful. So if you take the cross product of vector A with itself, that's always 0, right? Because the angle between a vector and itself is 0. And remember, one of the equations we had the sine of the angle in between those two vectors. So if the angle between them is 0, then the cross product gives you 0. And now the important one that I want to point out here is this second line. So if you take A cross B, that's actually negative B cross A. So the cross product can be kind of tricky, so order matters, because if you do it in the opposite order, it introduces a minus sign. So you do have to keep track of the order. Okay, so we've talked about torque, and just to close the loop here, so the last thing is we can actually calculate the torque vector with the cross product. So in the way you do that, so torque, the torque vector, right, is this vector r, which is the vector from your axis of rotation to where the force is applied, cross product with the force. Now, so in principle, this is the way you can calculate torque for any arbitrary vector r and any arbitrary vector f, although I will point out that actually for statics and for most of what we need, we won't actually have to go through all this gory detail. what we can do is actually we can just find the magnitude of the torque, right? And remember, this is our equation for the magnitude of the cross product applied here, right? So the magnitude of this is the magnitude of R times the magnitude of F times the sine of the angle in between them. And then for the most part, since we're kind of doing one-dimensional rotational kinematics, or dynamics, I should say, is for the direction, all we really need to know is if it's a counterclockwise or clockwise. And again, the usual convention is that counterclockwise torques we'll call positive, clockwise torques we'll call negative.